Everyone, today we're gonna solve another LEETCODE question called the two-sum. So if you're not familiar with the two-sum type of problem, I invite you to check out my previous LEETCODE question. It was also about two-sum. I invite you to solve it first or check out my previous video on how to approach those type of problem. And here we go with this one. So given an array of integer nums that is already sorted in non-decreasing order, find the two numbers such as they add up to a specific target number. Let these two numbers be index 1 and index 2, where index 1 inferior index 2. Return the indices of the two numbers, index 1 and index 2, added by 1. So we have two information. So they say that the tests are generated such as there is exactly one solution. You may not use the same element twice. Also, we are aware that we have to solve this solution in constant extra space. So here is an example. So let's just take that example and try to go through it. All right. All right. So now let's jump inside. So we have here 4 elements, and we have our target t equal to 9. And if you are also what I said at the beginning, if you are familiar with the two-sum problem, what we did the last time was to have a hash map, a hash set, and basically map all the elements that are inside of our array, inside of our hash set. And basically every time we just do a subtraction between the current element and the target number to see if it's already present inside of our hash set. And if that's the case, we can just return to the indices of those two elements. So that's what we did last time, and we could actually do that approach here and we will find the solution, but they informed us that we have to solve this problem in constant extra space. So let's see how we can do that. Here, to approach the solution is quite easy. What we have to do is basically have 2 pointers. So if you're not familiar with the 2 pointers technique, so I can go over it quickly. So the 2 pointer technique consists to have 2 pointer, and always keep track of those 2 pointer at inside of our array. So it actually helps us like reduce the time complexity and do our operation in constant extra space. So here, let's see how we can use the 2 pointer technique in this solution. So let's say that we have a pointer at the beginning and at the end. So we already know that the array is sorted. So we know that the next element after this current element, for example 2, is obviously bigger than that, and we know that the element that comes after the 50 before the 50 is inferior to it. So how can we actually solve it? So based on those information, if we have a pointer at the beginning and a pointer at the end, we can basically always keep track of those 2 pointers and add them. So let's say that we have 2 here and 15 here. If we add them, we have 17. 17 is actually bigger than our target number. So what do we have to do? We obviously have to decrease that number. So what operation can I do here that can help me reduce this correct sum? As you can see, it will be to move my right pointer by the left by 1. So that's what we can do here. So basically we can do that. Sorry. Okay, we can do that down here, and basically what we will have is okay, let me just delete that quickly. All right, so what we will have here is our pointer b at that will be at 11, and we will have a pointer at 2. And let's say that we addition those two elements. If we addition those two elements, we can actually see that the total number will be 13, and actually 13 is actually still bigger than 9. So how can we reduce that sum? It will be also to move our left pointer right pointer to the left by 1, and we reach to 7. And when we reach 7, we will have our target number equal to 9. And let's go here and let's remove this one. Sorry. So let's say that we had a 1 here, a 1 at the beginning, and we have a pointer that was at this position 1, and we still and and let's do again the walkthrough. So basically we have 1 and our pointer here, so it's 16. So 16 obviously inferior to 9, so we have to move our right pointer to the left by 1. So we have 11 plus 1, 12. So 12 still bigger, and then we come here, we have 7 plus 1, which is equal to 8. So as you can see, 8 is actually here bigger than inferior to 9. So what we have to do obviously is to increase our left pointer by 1 to the right. So we do that, we increase our left pointer to the right by 1, and we reach 2. And from 2 we have 2 plus 7, that is which will be 9. So that's it. So this is the 2-pointer technique, and we will obtain a time complexity of O of n and a space complexity of O of 1 with a constant extra space. So let's now go and write the code for it. So as I said, so we will have 2 pointers, so left and right, and which we can set to len nums -1 here, and do our for loop in range of len nums. Now what you have to do is basically check. So let's have a counter sum that we can initially set to 0, and counter will be equal to nums left plus nums right, and from there we have just to compare it and say, okay, if we have our counter bigger than the target, we have to obviously decrease our right pointer by 1. But if our counter is inferior to the target, we have to increase our left pointer by 1, and from there we can just return. So basically so at the end, so obviously if it's not either of this case, so it means that the counter is equal to the target, so we reach our maximum point. So what we have to do there will be to just return left +1 and right +1, But let's say that in the worst case scenario where we don't have any element, so basically we just have to return 0. Alright, so let's run it and see. Okay. Oh, sorry, I did a mistake here. So let me just change the variable name to nums. I got used to nums instead. Alright, awesome. So let's try now. Awesome. So that's it, and that's our solution for this code. So just give a like if you like this solution, and yeah, thank you, and see you again next time.